Hi everyone, my name is Chris Helm, and this week we are covering finite state machines. Now before we get into demonstrating the project and explaining how the code works and walking through the finite state machine I've created here, we should probably start off with a definition of a finite state machine. A finite state machine is a programming technique where the functionality of the program is dictated by the state that it's in. It will move between different states based on triggering events. Those can be values changed, it can be time limits. For games, it can literally be triggers or collisions. So in the context of AI, that allows us to change the AI's behavior based on game conditions. So I will pull up a map of the finite state machine that I have created right here. And before I walk through this, I'd like to point out that while I used an animator controller to map out the finite state machine for this video, the entire finite state machine is implemented in code, and this is just a visual representation of the states and the transitions. And it looks like a mess. So I'll do my best to walk everybody through this little diagram right here, and then we'll move on to an actual demonstration. So you're going to see that we have 11 different states. There's content, playful, lonely, aggressive, nervous, sleeping, sick, potty, thirsty, hungry, and then we have dead. Now, we can go to the dead state at any point in time from any state. If our AI's health reaches 0, the AI is going to die. In this case, we're using an imaginary puppy. The default state is content. The puppy isn't, our AI isn't, happy, it's not sad, it's not hungry, it's not thirsty, it's not tired. From content, we can transition to every other state from content. And when I walk you through the decision trees that are used for state transitions, I'll explain the hierarchy, how I've set up the hierarchy for these transitions. But the important thing is that from content, we can transition to each one of these other states. Now, playful, if the puppy doesn't have any other values that take priority, if the puppy has enough energy, just so that there's no confusion with the jargon, if the puppy's stamina is high enough, the puppy will become playful. When certain other values change, either the stamina will drop below the minimum level that's acceptable for the puppy to remain playful, or other game conditions will dictate that it changes state. It will transition to, if nothing else takes precedence and the stamina drops below the minimum stamina threshold, it will transition back to content. If hunger gets up high enough, it will become hungry. If thirst raises high enough, it'll become thirsty. If bladder raises high enough, it will have to go potty. If its health drops below the sick threshold, it will become sick. If the energy drops below the sleeping threshold, it will go to sleep. And if you startle it or make it mad, it will become aggressive. Playful, we don't transition to nervous because the line of thinking is that, you know, the puppy's full of energy, and if you scare it or you make it mad, the result is going to be the same because it's already amped up on adrenaline, so it's going to get mad. Now, if the affection is low enough and the stamina drops below the minimum stamina threshold for it to remain playful, rather than transitioning to content, it will transition to lonely instead, which is the next state that we're going to talk about. Lonely state, it transitions to lonely state when there aren't any other pressing issues and its affection is below the affection threshold, which is 50% of its max of the maximum affection. So if we raise its affection up higher than that 50% marker, it will transition back to content. Otherwise, if it gets hungry enough, it will become hungry. If it gets thirsty enough, it will become thirsty. Excuse me. If its bladder gets up high enough, it will have to go potty. If its health drops low enough, it will become sick. And if it gets tired, it will go to sleep. And if it gets startled, it will become nervous. It won't get angry when it's lonely because it's depressed. So we don't transition to aggressive from lonely. The next one is aggressive. This is dictated by anger, the puppy's anger stat. Once it becomes angry, there's not very many transitions. If anger drops down low enough, but the fear stat is still high enough, it will transition to nervous. If the anger drops low enough and the it isn't nervous, then it will transition back to content. And those are the only transitions that we have for aggressive. Now, the nervous state is dictated by the fear stat. If the fear stat is above the fear threshold, the puppy will become nervous, provided there aren't other game conditions that take precedence. Once the puppy is nervous, if you make it mad, it will become aggressive. If the fear drops down, before I talk about that, if the health drops down low enough while it's nervous, it will become sick. Now, if the fear drops down below the fear threshold and affection is below the lonely threshold, it will become lonely. Otherwise, it will transition back to content. Now, sleeping. While it's asleep, if it's while it's asleep, it recovers its energy. Sleeping state is dictated by energy. And once it goes to sleep, it won't wake up until either the player wakes it up by interacting with it, or the energy fills up to the maximum energy, or the bladder stat fills up to the sleeping bladder threshold, which is different than the not sleeping bladder threshold. So if its energy isn't all the way full, it only checks to see if it needs to go. It only checks the bladder stat, and if the bladder is high enough, it will wake up and go potty. If the player wakes it up by interacting with it, it will immediately become aggressive. it will become angry, and it'll get mad and it'll bark at you. If the energy fills all the way up, it will check to see if it's hungry. If it is, it will eat. If it's thirsty, it will drink. If it needs to go potty, it'll go potty. If the health is down low enough, it will become sick. And barring that, it will become content. Oh, if the stamina is up high enough, it will become playful. Over here in the sick state, the sick state is dictated by the player's health. If it drops below the sick threshold, the puppy becomes sick. And once it's sick, it doesn't check very many stats. It checks to see if it's hungry. If it is, it will eat. It checks to see if it's thirsty. If it is, it'll drink. If it needs to go potty, it'll go potty. And if it's tired, it will go to sleep. Now, if we raise the health back above the sick threshold, it will transition to content. If the puppy needs to go potty, once it does its business, it will check a bunch of stuff. It will check to see if it's hungry. If it is, it'll eat. If it's thirsty, it will drink. If it's still sick, it will become sick. If its energy is low enough, it will go to sleep. If its fear is high enough, it will become nervous. If affection is low enough, before we get to affection, if stamina is high enough, it will become playful. If affection is below the lonely threshold, it will become lonely. And if, barring all of that, it will become content. For thirsty, from thirsty, we can, once the puppy has checked to see if there's water, if there's not water there, it will wait for the player to give it water, and it will check its hunger and its bladder, and maybe I'd have to read through the code because the thirsty and the hungry transitions are the most complex, since there's multiple paths to get to hungry and potty. But if it hasn't drank yet, it will check to see if it's hungry, and if it is, it will try to eat. If it doesn't get water soon enough. If it needs to go potty, it'll go potty. If it doesn't get water soon enough. Immediately after it drinks, it will check everything else. If it's sick, it will become sick. If the stamina is up high enough, it will become playful. If it's hungry, it'll eat. If its bladder's high enough, it'll go potty. If it is angry, if its anger's high enough, it will become aggressive. If it is tired, if the energy is low enough, it'll go to sleep. If the affection is below the lonely threshold, it'll become lonely. Otherwise, it will become content. And finally, our last state that we can cover is the hungry state. The hungry state is really similar to the thirsty state. It will check for food. Once it checks for food, if there's no food there, it will periodically check its thirst and its bladder, and it will transition to one of those two if it needs to, if it doesn't get food quick enough. If there is food there, as soon as it finishes eating, it will check its thirst level and drink if it needs to. It will check its bladder level and go potty if it needs to. It will check its health and it will become sick if it needs to. It will check its energy and go to sleep if it needs to. It will check its anger level and become aggressive if its anger level is high enough. It will check its affection level. If it's below the lonely threshold, it will become lonely, and it will check its, and if it's not, if the affection level is above the lonely threshold, it will become content. So that is a rundown of how the state machine operates. That's really complicated. So let's close out of this, and I will show you guys the actual demo. So a little disclaimer before I press play and show you this in action. We are not using actual functionality for our finite state machine in this project. If you know how to program behaviors in the engine of your choice, none of that is going to change when you start implementing finite state machines. So in order to keep the focus on the finite state machine itself, we're using simulated functionality. And that is represented right here in this text box in the UI. Up here, this text box will always display the current state that the puppy's in. Over here we have our 10 stats. And then over here we have our interactions. Now, all of these stats are going to be affected over, they will all increase or decrease based on the state that the puppy's in, and then the available interactions will also be determined by the state that the puppy's in, and in some cases the specific functionality of the interaction will change with the puppy's state. So we'll go ahead and press play here. Now the first thing I'm going to point out is that there is a day-night cycle in this game. So it starts off at day and then eventually it'll switch to night. Now you'll notice that the puppy starts off in the content state. That's its default state, and then down here you're going to see that what it's doing is updated every so often. And these are the activities it can do while it's content. And here in just a second, now that the stamina got up high enough, it becomes playful. And before we go out of playful, you can see that the activities it's engaging in are different. And I missed it, so I'll have to wait until it's playful again. We're back to being content. So you can see right here we have our affection is at 93. If we pet the puppy, it's going to go up to 97, 98. So that directly increases the affection. If we play with the puppy, you'll see that affection goes up and stamina goes way, way down. Now that the puppy's thirsty, it's going to head to its water bowl and it's going to check for water. Now, if we don't give it water, it's going to periodically check its hunger and its bladder. And if those are up high enough, it will take care of those issues. We're just going to go ahead and water the puppy, and then as soon as it finishes drinking, it's going to transition to a different state. So we're back to content. Now, you notice the puppy just went potty, and it's daytime. So it immediately did that. Once it's nighttime, you'll be able to see that we changed the functionality of the potty state based on the time of day. Okay, so now that it's playful, we're going to kick the puppy. And I missed it because it went to sleep. But now that it was asleep, when I kicked the puppy, it became nervous. And you can see that its fear went way, way up. So now that the Now that it's nervous, if we pet the puppy, affection doesn't go up. Instead, fear goes down. Now that it's nervous, if we kick the puppy again, instead of it increasing fear, we're going to increase anger this time, and the puppy's going to become aggressive. And again, now that it's aggressive, if we pet the puppy, anger should have decreased right there. So now that we're down below the threshold, okay, so now it's nighttime and the puppy has to go potty. So now we have a new option. We can let the puppy out, or we can just let it sit there. If we let it sit there, it's going to go in the corner. Or we could have clicked this to let it out, and it would have gone outside. So you can see the interactions, they change as well as the actual functionality. Okay, so now that we're awake, we're going to, it's going to go get a drink. Earlier, I thought I watered it, but okay, so we'll go ahead and give it some water. Then it should transition to hungry. Make sure that we have food down for it. And now it should transition to playful, so I can show you this last functionality with the kick. Now if we kick the puppy while it's playful, nothing happens. The health doesn't decrease, and none of the stats change. So our affection is starting to get down really low, so we need to... Okay, so now if we let the puppy out, if it needs to go potty at night, it will run outside. So I'm waiting for this hygiene to drop down below 50 so I can show you the bathing interaction. So now that it's down below the hygiene threshold, we're going to go ahead and bathe it, and you'll see that we set our hygiene back up to 100%. If the hygiene drops down low enough, health will start decreasing. Also, if hunger gets up high enough and thirst gets up high enough, or energy drops down low enough, health will decrease. So now we will go ahead and do this so I can show you. Okay, so now that we've dropped our health low enough, we're going to get out of this. So now that our health is low enough, as soon as we finish going, as soon as he goes potty, going to fast forward through this. So since our health is low enough, the puppy is sick. Now we have this option right here to take the puppy to the vet. So we take the puppy to the vet, and the puppy gets some medicine. Now, after a delay, originally I had this set to 3 minutes, which is the time of the day-night cycle. Every 3 minutes it switches from day to night, vice versa. But for the sake of this demonstration, I set it down to 30 seconds. So here in just a couple of seconds, we're going to see that our health is going to get set back up to max health. And there it went. And then we have one last thing. So we have our hygiene is 70. We have our hygiene is now 72. So if we give the puppy a bath, this is not above the hygiene, or not below the hygiene threshold. So you see that it reset our hygiene up to 100, but it also wasn't good for the puppy, so we knocked health off. Give the puppy a treat whenever it's available. It will increase affection, and it will increase stamina. So last thing we're going to demonstrate. When our health reaches 0, the puppy dies. Okay, so that should have given you a good idea of how this operates. It changes state based on the stats and based on a hierarchy. Now, each state has its own hierarchy that it uses to decide which state to transition to, which we're going to get to in just a second. So, first thing, we have our game manager over here, and this is where we've implemented our day-night cycle, and we've implemented that as a finite state machine. This is really simple. Up here we've declared a delegate with a type of void state, no parameters, and then we've declared an instance of that delegate. In our start function, we have set our we've initialized our state to the day state, and we've initialized all of our other variables too. Now in the inspector over here, we have our day-night switch time, which represents that's the day-night cycle. That's how frequently it's going to change between one and the other. So over here we're using a timer, and once enough time has elapsed, we're going to change the skybox material so it will show the appropriate, so it will show the either the day or the night skybox. We are going to reset the timer, and then we are going to set our day Boolean variable appropriately, and then we're going to switch states. And then in the update function, we call state every frame. This is this is an incredibly simple finite state machine. It involves two states, and it switches between them at a set interval based on the value that we recorded in the inspector. Before we get to the complicated stuff, we'll talk about the UI manager. The UI manager just stores all of the variables, all of the components in the UI that where values might be modified, and then we have a couple of functions right here. We have our set stat text that we use to update all of our stat values in the UI, and then we have our set interactions, which we use to enable and disable the interactions. And we have our set activity, which sets our activity text, and then in the AI script, we set our state directly. So if we come over here, this is the AI script. And we have lots and lots and lots and lots of variables. Rather than run through what all of these are, I will explain all of them as we get to the functions where they're used in. The important things that I'm going to cover right now, though, are these string arrays that I've created right here. I mentioned that we're using simulated functionality, and these string arrays is where we store that simulated functionality, so that we can tell the player what the puppy is doing. Now, the content activities, you can see that there's one list. When we come down here to the play activities, though, you'll notice that there's daytime play activities and then nighttime play activities. And the thought process here is that the puppy is going to be outside during the day and inside at night. So the stuff that the puppy can do during the day while it's playing is going to be different than the stuff that the puppy can do at night. So we create two separate activity lists for the playful state. And the other states, we're only keeping a single list of activities for the other states that will use these. The potty state, the thirsty state, and the hungry state don't use these activity lists because the behaviors are hard-coded, so we actually display those behaviors in the state itself. So we come down here to the start function, and all we're doing here is we are initializing all of our variables, and we're going to set our state and initialize and finish initializing everything. And then in the update function, I mentioned that health is, when the puppy's asleep, health will gradually increase if it's below the max health. Now, if the puppy gets too hungry, we're going to induce a health penalty. If the puppy gets too thirsty, we're going to induce another health penalty. And if the puppy's hygiene drops down too low, we're going to induce a different health penalty. So we create this local float variable health mod, and we adjust it based on our hunger, thirst, and hygiene stats. We add that to the health modifier, and then we're going to update our stats. Once we've updated our stats, we are going to subtract the health mod from the health modifier, so that the health modifier, so that this effect isn't cumulative. If we don't do this, what happens is until it switches states, it will continually increase by whatever every frame. So we throw in this line of code to ensure that that doesn't happen. This right here is our death transition. If health is less than or equal to 0 and we're not dead, we're going to become dead. Right here we're setting our enum to the dead state. We are disabling all interactions except for the bury the dog. We set our the state, which is another delegate up here. We set that state to dead. We set our stat modifiers to 0, so stats are not adjusted, and then we set all of our stats to 0. Next, we display which state that we're in. The next thing that we do is we are going to update the stat text, so we're displaying up-to-date stat values. And then we are going to call our state functionality. And we'll get to all of that in just a second. Now, the set stat modifiers, we have this function right here called set stat modifiers. I have a series of private values that modify the rate at which these stats increase or decrease. So this allows us to change these, and these values, they will change based on the stat, or the state, sorry, that we're in. And then that plays a role in our update stats. Now, all of our all of these rates that we can see right here, our affection rate, stamina rate, fear rate, hunger rate, so on and so forth. These represent change over, it represents change per second. And I won't go into how I actually calculated these. I pulled out a calculator and decided on how quickly I wanted them to change, and calculated those values and then adjusted them after I tested things a couple of times. But in order for us to do that, what we're going to do is we are going to take the value, and we are going to add to that value the energy rate, or the rate of change, times the modifier, times time.delta time. Now, the time.delta time is important because that ensures that we are changing at this default rate per second. That's the rate of change per second. So time.delta time ensures that we maintain that constant rate. The modifier is used to either increase or decrease the rate at which it changes, and also to change the direction that it changes. So some of these stats you can see based on the rate of change. Some of these stats decrease over time by default, and some of them increase over time by default. So we use this modifier to change whether or not to change the rate, and to change whether or not they're increasing or decreasing, and then to ensure that the stats aren't going out of range. So, to ensure that we never have negative stats, and to ensure that we don't go over some cap that's impossible to recover from, we're going to clamp them between a minimum and maximum value for all of them. So now that we've gotten through that, we can get to the actual finite state machine. These next 10 functions, they represent the actual finite state machine. And before I talk about this, every single transition has a call to puppy transitions dot sum function. Normally, when programming a finite state machine, your transitions, the transition code is going to be included as part of the state's functionality. However, the transitions in this finite state machine are really, really complex, and it makes it by separating out the transitions into different functions, it makes it easier to understand what's happening with each state. So, for the content state, at a fixed interval, we are going to pick an activity, and we are going to perform that activity until it's time to change activities again. The activity that we pick is going to come from the activity, the content activities array that I showed you guys earlier. And then this last line of code, it resets the timer. So every fixed interval, we're going to select a random activity from our content activities to perform. And then the last thing that we're going to do is every frame, we are going to see if we need a transition. Now, this is important because for some behaviors, you want to transition. You might want to be checking your transitions every frame. As an example, a lot of times idle transitions, if you're in an idle state for an AI, you are probably going to want to check to see if you need to transition out of that idle state every frame. For others, like our potty state, which I'll cover in just a minute, you want to carry out entire behavior before you transition. So in our playful state, which is our next one, it's very, very similar to our content state in that at a fixed interval, we're going to pick an activity to perform. However, in this instance, the time of day affects what the actual activity is. If it's daytime, there's a list of activities that we can choose from, and if it's nighttime, there's a different list of activities that we can choose from. So the actual activity is dictated by time of day. And then again, down here, every frame we're going to see if we need to transition out of the playful state. Next up, we have our hungry. We have our hungry state. And this is, the first part of this is scripted. So we're not going to check for transitions every frame. As a matter of fact, at no point in time during the hungry, thirsty, or potty states do we check for transitions every frame like we do for most of the rest of them, most of the rest of the states. Rather, if the puppy's hungry, the first thing it's going to do is it's going to go to its water dish right here. And that's going to take a certain amount of time. Since the simulated functionality, we're using a timer to simulate that, and a bool variable to so that we can bypass this functionality in the future. So if we're not at the food dish, we're going to say that we are at the food dish. We're going to say that we're heading to the food dish, and then we're going to set a timer. Now, once enough time has passed, if we haven't checked to see if there's food yet, we're going to check to see if there's food. If there is food, we're immediately going to eat. If there's not food, the puppy is going to whine because its food dish is empty. And then we're going to set this check food to true, and we're going to reset our timer. This check food, by setting it true, ensures that we're not going to repeat this block of code again. So we go through this block of code once, and then after enough time has passed, we go through this block of code once. And then immediately after that, we are going to go through this entire block of code every frame. Um, if there's food down for us, the puppy's going to eat. We're going to reset our hunger to 0, and we're going to set a timer to represent the time it takes for the puppy to finish eating. And then this is important right here. We're going to set food to false to ensure that the player has to feed the puppy again the next time it gets hungry. Now, this block of code right here, you'll see that we've set a timer right here in the previous block of code, and then we're also setting a timer right here. So if we ignore this block of code right here, and we just go off of this right here, this ensures that that after a certain interval, the puppy is going to check for to see if it needs to transition to other states. To see if it needs to transition to other states. Now, if food has not been put down for the puppy, so we enter this else block right here. So food has not been put down. If the player feeds the puppy, we are going to reset this timer right here so we can continue to simulate the amount of time it takes for the puppy to eat. And then at regular intervals, we are going to see if it needs to transition. So we're going to see if it needs to transition immediately after it finishes eating, and if food isn't available at regular intervals, we're going to see if it needs to transition to a different state to perhaps manage a different stat. Now, the lonely state, again, this is really similar to the content state. The only difference being that the activities that we can choose from are different. Again, every frame we're going to check to see if we need to transition. Sleeping, again, is the actual code right here, the simulation code, is really similar to the content, the difference being the specific activities that the puppy has to choose from while it's in the sleeping state. And again, we're going to check every frame to see if it needs to transition. In the nervous state, again, it's the same thing. The specific list, the specific set of activities it can choose from changes. And we're going to check every frame to see if it needs to transition. The same thing with aggressive. And before I cover potty and thirsty, the same thing, we do the same thing down here with sick. The list of activities changes. And we check every frame to see if we need to transition out of the sick state. So we'll come back up here. Thirsty, the functionality, I just covered the hungry state. Thirsty is the exact same scripted sequence, the exact same sequence of events as the hunger state, but we're checking for water instead of food. And then the last major state is the potty state. Now, the potty functionality is determined first by time of day. So if it is daytime out, the puppy's going to be outside, so it's just going to automatically do its business. And if that's the case, we're going to set a timer right here. And then once enough time has elapsed, we're going to set potty to true, which will instantly trigger our transition code. In the potty state, we do not transition out of the potty state until the puppy has taken care of business. Now, if it's not daytime, if it's nighttime, the first thing we're going to do is we are going to enable the let puppy out interaction. Since it's nighttime, the puppy's inside, and the player has to let the puppy out. And we manage that using this Boolean variable can go. So at the start of, as soon as it enters the state, can go is immediately set to false. So if it is night, we're going to enter into this if-else block right here. The first time we run through this if-else block, this potty timer set Boolean is going to be false. So we're going to notify the player that the puppy's at the door and whining because it has to go potty. And then we're going to set a timer right here which simulates the maximum amount of time the player has to let the puppy out before the puppy can't hold it anymore. And to ensure that we don't repeat this block of code, we're going to set we're going to change this Boolean this potty timer set bool to true. So the next time we call this function, next time we enter this if-else block, we are going to bypass the if statement, and we're going to come down here, and we will only be accessing the else statement. Now, this right here, if the player doesn't let the puppy out soon enough, we are going to we're going to tell the player that the puppy couldn't hold it any longer. And to ensure that we're not repeatedly calling this, this is only available. This if block will only be entered into for a couple of frames, which is what this second, this first Boolean check right here is if enough time has passed. But to ensure that we don't repeatedly access this if block, we are going to ensure that once enough time has passed, beyond this this initial test, we will skip this if block again. And then right here is after enough time has passed to simulate the puppy going potty. We're going to set potty to true, which again triggers our transition. Now, if it's nighttime and the player does let the puppy go outside, we're going to notify the player of what the puppy is doing. Again, this potty timer set will be false. So what we're going to do is we're going to switch that to true. So the first time we enter this this if-else block, we're going to access this, and then every time after that, we're going to bypass this, and we're going to access this after enough time has passed. We're going to say potty equals true, and we are going to transition. The very last state is dead, and dead just displays one of two messages depending on whether the puppy's been buried or not. This is basically a lose condition state. So now that we've covered the finite state machine, and you can see how the functionality for each one of these states works. You can see what each how each one of these states affects what the puppy does. We're going to come over here to our puppy transitions. All the way up over here. Okay, like I mentioned earlier, normally transitions would be built directly into the state functionality. However, as you can see from right here with our content state, this is a fairly lengthy and complex decision structure right here. So I've opted to, for the sake of this video, I've opted to keep them separate so that so it's easier to see what's happening. So when we call the content transition, the very first thing we're going to do is we're going to check the health. And if the health is above the sick threshold, which is 1/3 of the max health, we are going to make our next Boolean check. Or we're going to make our next check. In this case, we're going to check to see if the puppy needs to go to sleep. If the energy is greater than the sleep threshold, which is 1/4 of max energy, we're going to move on and make our next check. In this case, it's going to be stamina. If stamina is over the enter play threshold, which is 80% of the max stamina, we're going to transition to the playful state. If we are not above the stamina, the play stamina threshold, we are going to check to see if the puppy is hungry. If the hunger stat is above the hunger threshold, we're going to become hungry. If it's not, we are going to check our thirst stat. If the thirst is above the thirst threshold, we're going to become thirsty. Otherwise, we're going to check our bladder. If the bladder is above the bladder threshold, puppy's going to go potty. And if it's not, we're going to check our fear stat. Now, when we check our fear stat, we're simultaneously going to check our anger stat right here. To see which one of these two states we need to go into. And this was a mistake while I was coding this. Really what I should have done for this hierarchy, instead of running a check right here to see if we need to enter the aggression state, I should have checked the anger stat against the anger threshold before the fear stat. So that's a mistake on my part. But it still works the same. So if the fear is over the fear threshold, but the puppy's not angry enough to become aggressive, we're going to go to the nervous state. If the anger is above the anger threshold, we're going to go to the aggressive state. And that's what we're also doing right here. If anger is above the anger threshold, we're going to go to the aggressive state. If it's not, we're going to check the affection. If our affection is less than the lonely threshold, we're going to transition to the lonely state. And if we make it to this point right here, then no change is warranted, so we're going to remain content. Now, down here, if back up here when we checked our energy, if our energy is lower than the sleep threshold, we're going to transition to sleeping. And then back up here, when we check our health, if our health is below the sick threshold, we're going to become sick. And then down here, this is where normally we would throw in our death transition, our dead transition right here. But we're handling, since we can enter the dead state from any other state, rather than including that transition, duplicating that transition in our transition code, we're handling that solely in the update function. So if we move on to our playful decision tree, the very first thing we're going to check is we're going to check our health. If it is above the sick threshold, we're going to check our energy. If our energy is above the sleep threshold, we are going to check our hunger. If hunger is above the hunger threshold, we are going to become hungry. Otherwise, we're going to check our thirst stat. If our thirst value is above the thirst threshold, we're going to become thirsty. If not, we check the bladder. If the bladder is above the bladder threshold, we're going to go potty. If not, we are going to do a simultaneous check right here. If fear is above the fear threshold, or if anger is above the anger threshold, we're going to become aggressive. If both of those tests fail, we're going to check affection. If affection is less than the lonely threshold, we're going to become lonely. Otherwise, if our stamina is less than our minimum stamina required to be playful, we're going to go back to content. And if we make it down to this else statement, we're going to remain playful. Now, when we checked our energy, if energy is below the sleep threshold, we're going to go to sleep. And if health is below the sick threshold, we are going to become sick. And then again, our death transition is handled in the update function instead of this. Now for hungry, you'll notice that we're passing in 2 Boolean values. If we come back over here and we look at our hungry state, we're using our Boolean at food dish, and we're using our Boolean check food. Those are private Boolean variables, and rather than make them public so I can access them directly, from the script, we're passing them in by reference. And then we're going to create 2 local variables, at food dish and check food, and we're going to set both of those to false. And the reason why is we set them to false here, and if, excuse me, if we remain hungry, we're going to set them to true right here. And then at the end of the function, down here, we're going to pass those values back to the arguments that we passed into the function when we called the hungry transition. That way, if we transition, those values get reset to false, so it doesn't mess up the scripted behavior the next time we enter the hunger state. And if we remain hungry, those variables remain true, so again, it doesn't mess up the current scripted scripted behavior. So this right here, the first thing we're going to do is we're going to see if the hunger is still above the hunger threshold. If the hunger is still above the hunger threshold, then the puppy has not eaten yet. And if that's the case, we are going to check thirst. If thirst is above the threshold, we're going to transition to the thirst state and try to manage that stat. If thirst is not above the thirst threshold, we're going to check the bladder stat. If bladder is above the bladder threshold, the puppy's going to go potty, so it can manage that stat. We're also going to check for fear and anger, and if either one of those is above the threshold, the puppy's going to become aggressive. And if all of those tests, if we make it down to this else block, meaning the puppy hasn't eaten yet, but it doesn't need to manage any other stats, we're going to remain hungry. If the puppy has eaten, we are again going to check our thirst stat to see if it's above the thirst threshold, and if it is, we're going to become thirsty. If it's not, we're going to check the bladder stat to see if it's above the threshold. If it is, we're going to have the puppy go potty. If it's not, we're going to check energy. If energy is higher than the sleep than the sleep threshold, we're going to check our health. If our health is below the sick threshold, we're going to become sick. If it's not, we're going to check the affection. If the affection is above the lonely threshold, we're going to become content. If it's below the lonely threshold, the puppy's going to become lonely. Now, if the energy was lower than the sleep threshold when we check that, the puppy's going to go to sleep. If we come down here to the lonely, we're going to run a health check first to see if the puppy is sick. If the puppy is not sick, we're going to see if the puppy needs to go to sleep. If it doesn't need to go to sleep, then we are going to see if the puppy's hungry. If it is, it's going to transition to hungry. If it's not, it's going to determine if it's thirsty. If it's thirsty, it'll drink. If it's not, it will check to see if it needs to go potty. If it needs to go potty, we'll transition to the potty state. If not, we're going to check the fear. Its fear stat. If fear is above the fear threshold, the puppy will become nervous. If it's not, then we're going to check the affection. If affection is above the lonely threshold, then the puppy's going to be content. And then if we make it down here to this else block, the puppy's going to remain lonely. If energy was below the sleep threshold down here, the puppy's going to go to sleep. And if the puppy's health was below the sick threshold, the puppy's going to become sick. Moving down to our next one, sleeping. The first thing we're going to do is we are going to check to see if the energy is at max energy. If the puppy's energy stat has reached max energy, it's going to see if it needs to go potty first. If it does, it's going to go potty. If not, it's going to see if it's thirsty. If it's thirsty, it'll transition to the thirsty state. If not, it's going to check its hunger. If it's hungry, it will transition to the hungry state. And if not, it will check its health. If the health is below the sick threshold, it's going to become sick. If that's not the case, it's going to check the stamina. If stamina is above the stamina threshold required to enter the playful state, it's going to become playful. If not, we're going to transition to content. Now, if the puppy is still asleep, up here, if energy is maxed out, the puppy is going to wake up. If energy is not maxed, we're going to check, do a dual check for fear and anger, and if either one of those values is above their respective thresholds, the puppy is going to become aggressive. If that's not the case, we're going to run a bladder check. If the bladder value is above the sleeping bladder threshold, which is 50% higher than the normal bladder threshold, the puppy is going to wake up and go potty. Otherwise, the puppy is going to continue to sleep. Now down here in our nervous, for our nervous transitions, the first thing we're going to check is fear. If fear is lower than the fear threshold, we're going to determine if we're going to see if the puppy's sick or not. If the puppy is not sick, we're going to check the affection level. If the affection is above the lonely threshold, we're going to become content, and if not, it's going to become lonely. If the health is lower than the sick threshold, the puppy is going to become sick. Now, if the fear is not below the fear threshold, meaning the puppy is, if the fear is still above the fear threshold, we're going to do an anger check to see if anger is above the anger threshold. And if it is, the puppy is going to become aggressive. Otherwise, the puppy is going to remain nervous. When we come down here to our aggressive, if the puppy is not dead, we are going to check the anger. We're going to check to see if anger is below the anger threshold. If it is, we're going to see if fear is above the fear threshold. If fear is above the fear threshold, the puppy is going to become nervous, and if it's not, we're going to transition to content. If that's not the case, the puppy will remain aggressive. If the puppy's dead, that's going to be handled in the update function. This is another mistake I made where I refactored my code and missed this right here when I was removing the death state from all of these transitions. So in the potty state, we don't have to do a bladder check, unlike the hunger and the thirst, where we're checking to see if the puppy is still hungry or still thirsty, or the playful, where we're checking to see if it still has some stamina. For potty, it doesn't transition until it's gone potty, so we can bypass the bladder check. So the first thing we're going to check is its health. If it is above the sick threshold, we're going to check its energy. If its energy is above the sleep threshold, we're going to check its stamina. If its stamina is above the threshold required to enter the playful state, it's going to become playful. Otherwise, it's going to check the hunger. If its hunger is above the hunger threshold, it's going to become hungry. If not, it's going to check thirst. If thirst is above the thirsty threshold, it's going to become thirsty. If that's not the case, we're going to check fear. If fear is above the fear threshold, it's going to become nervous. Otherwise, we're going to check affection. If affection is lower than the lonely threshold, we're going to become lonely, and if not, it's going to become content. Now, if energy was lower than the sleep threshold, it's going to go to sleep. And the very first check, if health was below the sick threshold, it's going to become sick. when we come down here to our thirsty transition, our thirsty transition is pretty much the same as our hunger transition. Excuse me. Um, these reference parameters that are required to be passed in, we handle those the exact same way we handled the hunger. So we create our two bool variables and set them to false. If we remain in the thirsty state, we set those to true, and then before we exit out of the function, we pass those values back to the variables we passed into the function by reference. That way we never screw up the scripted behavior. So the first thing we're going to do is we're going to see if the puppy is still thirsty. If the puppy is still thirsty, we're going to see if it's hungry. If it's hungry, it's going to transition to the hungry state. If not, it's going to check the bladder. If bladder is above its bladder threshold, it's going to go potty. And then it's going to run a dual check on fear and anger. If either one of those is above their respective thresholds, it's going to become aggressive. And if that's not the case, it's going to remain thirsty. Once the puppy has finished drinking, which is this, which starts right here, we're going to check hunger again. If the puppy is hungry, it's going to transition to the hungry state. If not, it's going to check its bladder. If its bladder is full, it's going to transition to the potty state. If not, we're going to check energy. If energy is above the sleep threshold, we're going to check health. If health is below the sick threshold, it's going to become sick. Otherwise, it's going to check stamina. If stamina is above the stamina threshold required to enter the playful state, it's going to become playful. If not, we're going to check the affection stat. If affection is above the lonely threshold, it's going to become content. If not, it's going to become lonely. And then down here, when we made our energy check, if energy is below the sleep threshold, it's going to go to sleep. And then we have our last transitional code right here. The first thing we're going to do when the puppy's sick is we're going to check the health. If health is above the sick threshold, the puppy is going to transition to content. If that's not the case, if the health is still below the sick threshold, we're going to check the energy. If the puppy's not dead, we're going to check the energy. If the energy is above the sleep threshold, we're going to check its hunger. If the puppy's hungry, we're going to transition to the hungry state. If not, the puppy's going to transition to we're going to check the thirst value. If the puppy is thirsty, it's going to transition to the thirsty state. If not, we're going to check the bladder. If bladder is above the bladder threshold, it's going to go potty. Otherwise, it's going to remain sick. Now back down here where we check the energy. If energy is below the sleep threshold, it's going to go to sleep. So those are the way the transitions work. And then the last thing I've done right here is rather than directly transitioning to the state in each one of those, transitioning actually requires several steps, as you can see right here. So we've created a function to actually transition to those states where the state delegate is set to the appropriate state function, and then we're going to set our stat modifiers. This right here is how we determine whether the stats are increasing or decreasing during that state, and also how we affect the rate of change. So health, which is this final one, I know I used magic numbers here, but if I had written out variables for all of these things, it would have required 90 or 100 variables to track everything. So I apologize for the magic numbers, but this was faster for this particular project. So we're going to set the stat modifiers right here. We're going to reset the timer to 0. we're going to adjust the enum that represents the current state, and then we are going to we're going to enable and disable the appropriate interactions right here. Now, the reason I've done this is because I could have included this code. We hit Control C, and we come back up here to the content state. I could have included all of that stuff right here, with the exception of this. I could have done this, and then especially for the set stat modifiers, we have that function available right here, so we can see, we can make the reference right here to see what all of these values are affecting, and then for the week 4, and then for the interactions right here. But this is actually a really, really bad practice to do it like that. Oh, we couldn't set the timer right there either. This is a bad practice because each one of these functions requires several operations to perform, and that eats up valuable processor cycles, valuable CPU cycles. Since this state is called literally every frame, what you end up doing is you end up calling the set stat modifiers every frame, which requires n number of CPU cycles to call it, to reference the variables, and to adjust the values stored by all of these variables. And then the same thing with this. It requires a set number of cycles, and it's doing that every frame, which which really adds up on the number of CPU cycles it takes to run the state functionality. So rather than do that, all of this stuff, it actually only needs to be set once, because once we enter one of these states, the stat modifiers, they're not going to change. Once we enter a state, the available interactions are not going to change, with one exception. So we have these content transitions, so we can help keep these decision trees up here cleaner. It's easier to see what's happening. We can see that we're going to transition to the hungry state right here, and so it keeps the code, our decision trees, cleaner up here, and we're only calling this functionality once when we transition, and we're never going to call it again, which helps improve the efficiency of the code. And I've done that for every transition, with the exception of the death transition, which is handled solely in the update function right here. The last thing that we need to cover are our inputs. I have a separate script for the inputs, and there are 10 of them. So the first input, the first thing I'm going to mention is that we have an interaction cooldown. Right now it's set to 3 seconds. Whenever the player interacts with the puppy, this disable interaction function is called, where we set can interact false, and then we set our cooldown timer. And then in the update function, we see if we need to re-enable interactions, and if we do. So if interactions are disabled and enough time has passed, we set this can interact to true, and that enables the player to interact with the puppy again. So for the pet interaction, I'll talk about the default first. The default for all of the states, except for the cases that are listed above this, it's going to increase affection by 5% of the max affection. In the case, and that's for everything except for unless the puppy is in the aggressive state, the nervous state, or the sleeping state. If the puppy is aggressive, instead of increasing affection, instead of adding 5% of the max affection to the affection value, we're going to subtract 10% of the anger threshold from the current anger value. If it's in the nervous state, we are going to subtract 10% of the fear threshold value from the current fear value. And if it's sleeping, we are going to make the puppy incredibly angry, set the state to aggressive, and set the state to aggressive. So it's going to immediately wake the puppy up and make it mad. And then the last thing is we are going to put interactions on cooldown. Now, play, for those functions where it's available, for those states where it's available, we are going to decrease stamina. This was actually supposed to be 5%. We're going to decrease stamina by 5% of the max stamina. And we're going to increase affection by 5% of the max affection. Now kick again, we have a default state, a default functionality that happens if the puppy is not aggressive, if it's not nervous, and if it's not playful. The default functionality is we are going to increase, set fear to 1.5 times, or we're going to add 1.5 times the fear threshold to the current fear value. And we are going to decrease the puppy, we're going to subtract 20% of the max health from the current health value. And that's the default. Now, if the puppy is aggressive, we are going to double its anger value, and we are going to subtract 20% of the max health from the current health value. If the puppy is nervous, we are going to add 150% of the anger threshold value to the current, or no, we're going to set anger to 150% of the anger threshold value, and we're going to immediately transition to the aggressive state. And we're going to subtract 20% of the max health from the current health value. Now, if the puppy is playful, the kick, instead of it being, something that's going to hurt the puppy, it's going to be a playful kick that the puppy is going to dodge out of the way, and we're not going to have any stat changes. The treat interaction, we're going to add 5% of the max stamina to the current stamina value. We're going to decrease the hunger value by 5 times the hunger rate. So 5 seconds worth of hunger change. We're going to decrease hunger by that amount. And we're going to increase affection. Again, that's supposed to be by 5% of the maximum affection. Now, these next two, feed and water, all we're going to do is we're going to put down food for the puppy, or we're going to put down water for the puppy, which enables the puppy to eat and drink respectively. For the potty interaction, this is only available at nighttime if the puppy needs to go potty. And all this does is enables the puppy to go outside to go potty at nighttime. So back up here to the bath. This one isn't affected by time of day. This is affected by the hygiene value. So when the bath interaction is available, we're automatically going to set our hygiene value to the max hygiene. However, if the hygiene is greater than the hygiene threshold, we're also going to say it's bad for the puppy, because bathing dogs too often is bad for them. And so we're going to penalize them by taking away some health, in this case 10% of the max health from the current health value. Down here in the vet, this is only available if the puppy is sick. So this allows the player to take the puppy to the vet, where the vet's going to give the puppy some medicine. And then down here we're going to start this co-routine, heal puppy, which after a set amount of time, initially I had this set to 180 seconds, which is the same time I had the day-night cycle set to. But for the sake of demonstration, I decreased it to 30. So after a set amount of time, we're going to set the puppy's health value to max health, and that will fully heal the puppy. And then for the dead interaction, which is only available if the puppy dies, we are going to set the buried Boolean value variable to true, which simulates the player burying his dead pet. So there's a lot of complex stuff going on in here, but only because of the number of states and the number of transitions available for each state. But hopefully this has given you a good idea of how to work with finite state machines, what they are, how they function, and if you have any questions, feel free to ask, and thanks for watching.